Hello, this example is for the two-sample proportions test using StatCrunch to do the calculations. In StatCrunch, you're going to use, the menu is going to be Stat, as usual, Proportions, because this is two-sample proportions test, then two samples, because you're dealing with two-sample test, and then with Summary, because you're going to just give the number of successes, the number of attempts for each of the two samples. To perform the two-sample proportions test, you're going to need four numbers. It's going to be the number of successes and trials for sample 1 and the number of successes and trials for sample 2. So for our example, the number of belted drivers who slowed down was 19 out of 739, and the number of non-belted drivers who slowed down was 2 out of 306. To see this in StatCrunch, again it's Stat, Proportions, two-sample with Summary. And bring this up and you've got four spaces to fill in. Number of successes and observations for sample 1, number of successes and observations for sample 2. So for us it was 19, 739, 2, and 306. Next, it's going to ask if you want to do a hypothesis test or a confidence interval. Let's do a hypothesis test. And we are saying that the belted driver proportion is going to be higher than the non, so this will be greater than. And then calculate. And here's what pops up. The z statistic is 2.01, and the p-value is 0.0222. Because the p-value is less than alpha, we reject the null hypothesis, conclude that the proportion of the belted drivers who slowed down is greater than the proportion of non-belted drivers who slowed down. That's all there is to it. Hopefully this made some sense. Good luck. Have fun.